Good morning, sir.
Good morning. Who is there?
Jatin is here, sir.
Yeah. Good morning, Jatin bhai. કેમ છો?
Boss, ekdam fine, sir. How are you?
Yeah, doing well. Can we check my presentation?
Sure, sir. Sure.
Yeah, just sharing with you, and then we'll remove it.
It's
Is it
visible, sir.
visible now?
Yes, it's visible, sir.
Yeah, if I make it full screen, then it would be much better, perhaps.
Yes, it's perfect, sir.
Perfect. Okay. Let me check one by one. Actually, my laptop is a bit slow, so maybe it may happen that it may get stuck up for 10 second, 15 second during presentation. But we'll manage.
Yeah, okay, no problem. Sir, now it changed.
Yeah. We'll have a very good presentation.
Yep.
It will be in the આપણે ત્રણ પાર્ટમાં કર્યું છે.
Okay.
પહેલું આપણને જે આઈઆઈટી રામને જે ઇક્વિપમેન્ટ મળ્યા એના છે 2 સ્લાઇડ. પછી આપણે જે ઇલેક્ટ્રોનિક જે આપણને કમ્પોનન્ટ મળ્યા છે આપણે ડિઝાઇન લેબ તરફથી આપ્યા છે ઇન અધર વર્ડ્સ એનું થોડું ડિસ્ક્રિપ્શન છે ફોર 15 મિનિટ્સ અને 15 મિનિટ્સ પછી અમે જે પ્રોજેક્ટ કર્યા છે એનું ડિટેલિંગ છે. This is the project.
Wonderful.
We have done. I will show you the videos also. Video. દેખાય છે video?
Yes, I can see it.
Okay, great. ચાલે છે ખરું એટલે બહુ વાંધો નહીં આવે presentation.
નહીં આવે sir. Yes, it will run very
well. This is what we have done in lab. આપણી ડિઝાઇન લેબ થી આપણે આ બધું કર્યું છે.
વાહ.
આ છે ને ફ્લાઇંગ બર્ડ બનાવ્યું છે આપણે. Can you see?
Yes, sir. It's wonderful.
Wonderful, ના?
Yes.
હા. એટલે નીચે જો Arduino દેખાય છે.
Yes.
યુઝ કર્યા છે ને?
Yes.
હા. અને આ ટેલ છે એની. ત્યાં અહીંયા પણ આપણને Arduino દેખાશે અહીંયા.
Yes.
જે આપણે કમ્પોનન્ટ ડિઝાઇન લેબ નો યુઝ કર્યો છે.
Yes.
અને આ પાછળની એની જે ટેલ છે ને એ
ટેલ. Okay. હા.
જે બોર્ડ હોય ને એની
બોર્ડ ની. Yes.
થર્મલ કેમેરાનો ઇન્સ્પેક્શન કર્યું છે આપણે. ક્યાં આગળ તો કે અહીંયા આપણે સબસ્ટેશન ઉપર
ઇલેક્ટ્રિક ઓપન
એટલે આ બહુ નાઇસ એપ્લિકેશન કરી છે આપણે થર્મલ કેમેરાની. આખું થર્મલ કેમેરાથી આ આખું સબસ્ટેશન ફોલ્ટ ફાઇન્ડ કરી શકાય. જોઈ છે અહીંયા ફોલ્ટ દેખાય છે.
Yes.
એટલે આ એનું પિક્ચર છે અને થર્મલ કેમેરામાં એ આવું દેખાય છે એટલે ટેમ્પરેચર દેખાય એમ.
વાહ, વન્ડરફુલ.
હજુ તો જુઓ તમે આગળ આ એક ડ્રોન બનાવ્યો છે આપણે.
Because this is a real applications. Science ની real science.
આ જુઓ તમે. આપણી નવ હોય ને નવ સિગ્નલ સેન્સ કરીને આ એક આપણે આમ બનાવેલો છે વેબમાં.
ઓકે, હા.
બીજી ઘણી એપ્લિકેશન્સ અંડર ડેવલપમેન્ટ છે, હું બહુ રિવીલ નહીં કરું કારણ કે પેલું રિસર્ચ લેવલ પર છે. આ એક રિસર્ચ પ્રોજેક્ટ કર્યો છે આપણે.
હા ના સર, ઓવરવ્યુ બી થશે તો બી એ લોકોને ઘણો બધો આઈડિયા આવી જશે.
એટલે છે ઘણું બધું. આપણે અડધો કલાક છે ને મારી પાસે ટાઈમ, આઈ થિંક.
હા સર, 45 minutes.
Okay, so it is working, so there won't be any problem.
No problem, sir. No problem.
As far as presentation is concerned.
Yes.
Okay, so we have
Sir,
time.
we will start in 5 minutes, sir.
I'm ready.
Okay. IIT Bombay. Sir has also pursued his postdoc research studies from University of Cagliari, Italy. Sir is active member of more than 10 forums and societies of academia and industries. His research papers has been published in so many prestigious journals. In fact, his research has also earned 5 patents published in his name. So, sir is also a member of expert technical committees who helped us to conceptualize and design the concept of design lab. So, we are very much thankful to Akshay Mehta sir for being with us and guiding us all the way to set up this fantastic facility in various colleges. So, thank you very much, sir, for your kind consent and being with us and sharing your knowledge. Sir will take us through the electronic part which has been delivered in the design labs. We all know that students are very much interested in Arduino Pi, Arduino Starter, Raspberry Pi, IoT board, GPS module. So, sir will give a very brief information about them, and he will also, tell you that how can you utilize these functions and the tools to build innovative projects. So very welcome, very warm welcome to you, sir, and I'm handing over you for delivering the sessions. Thank you very much.
Yeah. Shall I continue?
Yes, sir.
Okay. So let me share with you all the presentation first. Yeah, I think it is visible.
Yes, sir.
Okay. Let me make it full screen so that much clearly visible. Okay. Thank you very much, Dr. Jatin Pandya. And I am really thankful to DST-GUJCOST and particularly Saucer for giving me the opportunity to associate myself with this design lab project. I know way back in 2018, it was the first meeting which was called up by Saucer, and he put forward this concept. Shall we make such laboratory which will give hands-on practical knowledge to our students, and most important is that they'll go away from the fear of this hardware. So then the eminent people in a committee from various institutions, they deliberated and discussed on that, what kind of equipment we can give to the students of the engineering college so that, they can work on that, they can carry out their projects. Not only that is the one agenda, but the hidden agenda was that, if they want to implement their novel idea, innovative idea into a physical device, then also they need not to loiter here and there for getting the equipment. In this laboratory, they can come and easily they can get the whatever the equipment they want for their disseminating their ideas. So subsequently, we decided we'll give some equipment in various domains, and accordingly there are some 5-6 domains in which equipments were given. And let me tell you, we are very much thankful to Saucer, who has constantly guided us, in this matter. So today I'm going to give a very small presentation on various electronic kits which is given in this design lab, and how one can use these electronic kits, for developing some projects. Okay, I'll also show you some of the projects which we have carried out at our laboratory, where we have used some of the lab equipment, and still it is going on. Many projects are under pipeline, and we'll be able to complete it by end of this academic year. Let me come to the first point that IIT Ram is one of the Fortune Institute that is awarded this design lab by Honorable Chief Minister on the 12th December 2019, and then subsequently we got the equipment in the month of February, and then we inaugurated this laboratory in the month of February. But unfortunately, from the month of March, we got the lockdown, and still the colleges are not open for physical form even today. And that is why we could not take the maximum advantage of this equipment. But however, we have done our best to utilize these resources. And as soon as the the colleges and universities will be granted to open by the government, we will definitely use these resources very, very extensively. So here you can see our Honorable Director General is receiving this Design Lab Award from Honorable Chief Minister and a certificate from him. And here in the picture you can see he has inaugurated this Design Lab, and this Design Lab, the people who are active in this Design Lab are also over here. So you can see that many equipments are given. I'm showing you the pictures. Sorry, it's hang up for a minute. Yeah. So you can see in a Design Lab, we have got the sensors, the web cameras, thermal cameras, the processors, Intel boards, mini laptop or computer you can see. Then we have many small kits in the form of Arduino. Then we have got the PCB prototyping machine we have got. Then power supply also we have got. So various equipments are there in this design laboratory, and today I am going to tell you some of the equipments which we have got as an electronic kit, in the form of electronic kit. So the first and most important kit which we have got under this design lab is the analog discovery. Perhaps many of you have not used this in your lifetime, but if you are coming to this design lab, you will be able to find all 4 equipments in one small handy kit form. What are these 4 equipment? You can say oscilloscope, it is a function generator, it is a logic analyzer, and it is a network and spectrum analyzer in a one board, and it is a very handy equipment. So as a electrical engineer or an electrical or electronic engineer, this board you can bring it anywhere, and you can capture the signal, and you can use this kit for getting the signals. You can analyze and you can see the waveforms. Not only that, you can get the function generator with this. So you want to apply any signal to any of your equipment for analysis purpose, you can generate the waveforms. So here in this kit particularly, you are given 2-channel USB digital oscilloscope and 2-channel arbitrary function generator, 16-channel digital logic analyzer and pattern analyzer, and along with that you have the network analyzer and spectrum analyzer. Very, very important kit we have, and very handy. You don't have to carry your bulky CRO, bulky function generator, nothing. You bring a small compass box kind of device you have, and you can bring it to anywhere and you can use it. Okay, so you can use for any we have, that is Arduino Starter Kit. We have not given only the kit, that is your Arduino board. We have given you the entire kit, which includes a lot of things. So in this, you are having Arduino Uno board, then you can have one USB cable so that you can connect with your PC. Then you have wires, you have breadboard, you have sensors on this. You have a phototransistor, potentiometer, you have temperature sensor, you have tilt sensor. Tilt sensor is very very beautiful thing, so that you can fly your drone, or you can have a robo, or you can have a bird, or you have any aerial robo which you can use, and you can use this tilt sensor to get the angle of the tilting angle, another way you can say. This kit is also including the one piezo capsule, one small DC motor, one servo motor, and optocoupler, two MOSFET transistors, capacitors, resistors. Lot of things are there along with this. You can use the components, and you can make your own device, or your own product, I would say. And then you can even patent your idea. There is nothing like that you cannot do. So this is the Arduino Starter Kit, and let me tell you, we have used it for one of the innovative project in our laboratory. I will show you in my second half. So the next one is your Bluetooth chip module. So when you want to communicate with the other devices, you need some chips, using the Bluetooth technology. So you have this module with UART interface. UART interface means Universal Asynchronous Receiver Transmitter. Is one of the simplest and oldest form of device to device digital communication. So you want to make some device, on your robo, that it should not collide with each other, or you want to identify there is some obstacle is there or not. You can use this Wi-Fi based, sorry, not Wi-Fi, Bluetooth chip module for your project, and some specifications are there. It is using a frequency of 2.5 gigahertz ISM band modulation. It is GFSK modulation. Then emission power is there, sensitivity is there, and it is compatible with your power supply, so that you can give power to your Bluetooth chip module. Okay. Extensively you can use this module, and many projects can be done where you want to communicate from one device to another device. Okay. Then you have a drone kit, but unfortunately this drone kit was under this docket, but unfortunately we could not get the DGCA permission, and that's why we could not avail this drone kit. That's why I will also skip it. Otherwise, this drone kit is a very beautiful kit, which is not having only drone, but along with its cameras and various sensors, everything was there, but unfortunately we could not give it in the second lot. In the first lot we have with us, so I'll not go into that. The next kit is GPS and Wi-Fi chip module. So it's a combination of GPS plus Wi-Fi, and let me tell you, this GPS module, you can use it for various tracking purposes. Even let me tell you, one of the project which was conducted by IIT RAM is that you can measure the growth of the plant using the GPS. So you'll say, how is it possible? So we have set some sensors there, and through sensor we were identifying the moisture level as well as the growth of the plant by some sensors, and that we were transmitting using the GPS module. Okay, and in conjunction with Wi-Fi chip module, you can carry out numerous innovative projects, in your laboratory as well as wherever you are working. Then we have also with us, that is Intel Atom IoT board. Let me tell you, the IoT projects are most searched projects by BTech students across the discipline. Across the discipline, what I mean, it is not only the electronics engineers who are working on that. It is electrical engineers, IC engineers, mechanical engineers, civil engineers are also using now these IoT boards. And let me tell you, very recently we have also used this IoT board for monitoring of transformer parameters. because you know that recently we have seen a lot of accidents in Surat. We have seen one accident. We have got the fire, and many our students or the young kids died in that accident. And very recently, in the month of April or May, we have seen one of the fire in Ahmedabad also at Ashram Road. And in both the cases, the fire was because of your transformer. Okay, so if we can develop some application which can monitor the parameters of the transformer across your area, it may be 100, 200 transformer. So using this IoT kind of board, that is possible. So you have to have some protocol which can get your data on your server, and then you can develop some machine learning algorithm or artificial intelligence based algorithm which can tell you, the abnormal transformer. Okay, and so immediately you can cut off that transformer, and you can avoid the accident. Okay, I would say. So this is a very good Intel Atom IoT board is there, and which you can use for many purposes. You can make your what you call the smart home. That is very relevant application, but that is not the only application. You can use this IoT board for tracking and tracing a lot of other things, using the sensors. So I'll show you what we can do in our laboratory also. Then next we have IoT and embedded development kit here, which we have the entire bunch of kits, you can see, where you can have the Arduino MKR IoT bundle, MKR wide area network 1300 IoT board is there. Then Arduino MKR 0 with header is there. Then you have the embedded system is also there. So for that, we have a ARM Cortex-5, which is general purpose development board, which you can use it for embedding your other devices, So, various kits are also available in this laboratory. Then with this kit, you have, wireless MCU launchpad is also there, and you have a smart vision sensor is also available. So, you can connect your devices with this board, and you can configure it with your programming, So this is a very nice kit. You can use it. Then we have a smart home kit. Here you can make your entire home smart. All kinds of sensors are there which are useful for making your home a smart one. Very recently, the GE, then these are working on the smart home products, and very soon in the market we will see very nice kits available for our home applications. Even today it is available in the market, but it is not that much popular. But if you can develop your own smart home kit, and if you can patent it, and then you can have your own startup, let me tell you, huge prospects are there for this kind of startup, because every home wants their home to be smart one, So here in this kit, you have given the IR transmitter, then light sensor, then you have, a MP3 player, servo sound trigger, then you have split speaker, temperature sensor, many more things is possible, and it is having the interface with your mobile as well as the computer. So using your mobile only, you can you can open your curtain, you can open your door, you can reduce the illumination of your light system, you can turn on and off your music system, your refrigerator. Many more things is possible. You have to think on that. How is it possible, and how can we use this particular home network based smart home kit, which you can use. Now next one is a very important kit, that is humanoid, which is given to all the labs to carry out how to do the programming, either in Python, or you can use its own language which is given with this kit. Okay, let me tell you, with these humanoid you can make fun out of it. You can make all kind of motions with this robot. Okay, so what is there? This is a Wi-Fi wireless control robot is there, which has 18 degree of freedom. 18 degree means 18 types of motion is possible. So you can see number of motion. It has the head. It has the arms. So these two arms have also some 3 degree of freedom. In the 3 motion it can have up, down, and in horizontal direction, and plus horizontal plus vertical direction. Both combination of that. Then its body can be moved. Its leg can be moved, and lots of application can be done. Let me tell you, one of our student has developed a very nice, it is an exercising protocol for this kind of robo, or in other words, they developed the algorithm where this robo is doing exercises. Different postures are developed for yoga. So you can also develop such program, and it gives you a very good hands-on practical training. So what is there in this? You have 12-gram high sensitivity power metal gear servos are there, and you have body parameters like full body height is this 20 centimeters. It's a very small robo, and you can develop different kinds of motion with that. You can make him dance. You can make him to move in one direction, other direction. You can make it doing exercise. Lot of things can be possible. So it's giving you a very good idea how to write program. Okay, and it has the analog servo. It has very high accuracy and zero dead zone. Zero dead zone, so that robot movement is more agile. More agile means very neat. It is not kind of switching kind of motion. It is very elegant motion you have. So you can use this robo, and definitely this robo can be used and controlled wireless with your own desktop or with your own mobile even. Okay, so you can carry out the things on this. Let me tell you, the next kit is a Raspberry Pi, similar to your Arduino Uno board. The Raspberry Pi board has also got very good functionalities, and you can program it, and you can use it for many applications for your automation purpose. Okay, so these are the some of the what you call the specifications are there of this board. It has got the Pioneer 600 expansion board, and it has the temperature sensor. It has infrared remote controller, IR control. The sensor is there. 8 GB micro SD card is there. USB camera is given along with this, so you can use it for surveillance purpose. Then touchpad is there with wireless keyboard is there. Then not only that, you have a HDMI to VGA converter is also there, so you can convert your signals into VGA form. And along with that, you have the LCD is given, and interface with the touch interface is also given. So this is a very beautiful kit. You can use it for you can learn how to program this kit, and you can develop your own models on this kit. Okay, so these are the things which are given, and along with that, you are also given some solar kit for indoor purpose and outdoor purpose. So along with your power supply, you can use your solar panels for getting the power. So with this, I am stopping what equipment which we have in our laboratory, and will show you now that what kind of applications we have developed in our laboratory. Okay, so let us see. We are using this laboratory equipment kits for various UG, PG, and not only UG and PG projects, but we are using it for the research project. So one project which is carried out, that is how to prototype an ornithopter. I'll give you what is that ornithopter. We have used the brushless DC motors and some sensors for this purpose, and Arduino Uno also used. Then we have used the thermal imaging camera which we have used. Of course, our next speaker is going to talk on that. So I'll not go into detail of this thermal imaging camera. Professor Nitin is there from IIT Gandhinagar. So he will tell us more on this, how to use this thermal imaging camera. But we have used this thermal imaging camera for our, for monitoring and preventive maintenance purpose of substation equipment. Okay, we'll show you what we have done. Then we have also developed one drone in-house, and we are trying to control this drone flight using some sliding mode control. It's a non-linear controller, okay, where we have used Arduino Uno kit and sensors. We have also developed some condition monitoring system using our IoT. Then we have also developed some Li-Fi or visible light communication system. We tried to develop some hub which is using the visible light. Okay, so these are some UG projects which I have told you. One more project is also going on at UG and PG level, that is about the grid integration of various renewable energy sources. I'll talk about that in one slide. And the last one, that is your electrokinetic stabilization of saturated soil. Okay, this is a research project, and our components are used in this PhD work. That is your DC supply and Arduino Uno kit. So let me begin with the first project which we have done. That is your Ornithopter. Ornithopter is nothing but it is a prototyping a bird. So if you can make a robot which can fly like your bird, and it has got a lot of application in surveillance, and not only surveillance, but in future it can be used for delivery purpose and many more purposes. Perhaps you have seen such device in one of the movie, that is Uri, and that is what we are working on it, and we have tried to develop this thing. So we began with one gear system, and in a CAD we developed the module first, but we could see that it is not as accurate as it should be. Both the wings are not synchronized. It is going as at different angle it is operating. So what we did, we applied the 2-gear system. So you can see that the motion of your wings have become more smooth, and it is giving more impact while it is going down. You can see it over here. So you can see that this is the complete model which is developed using the gear and our servo motors, which are given in our design laboratory. So you can see it is flying very elegantly, very nicely. So then we, after developing a CAD model, simulation model, we went into the hardware design. So you can see this is the hardware which is developed in the laboratory, in our laboratories. So this is a gear system which is developed using 3D printing, let me tell you. And here you can see one servo motor is there, which is used over here. Okay, so this is developed, and then you can see the entire model which was developed here. You can see with the DC motor, you can run it. You can see. So you can make slow and fast. Okay, so this is one of the project which we have developed. This was this two were the wings, and for its tail also we have developed. So here you can see Arduino kit is there, which is given by our design lab, and one motor which we have used along with this gear. That motor is also given by the design lab. So here you can see the tail can be also moved, so that you can move your Omnithopter in certain direction, and you can control the trajectory. Okay, it is under still this project is under the research, and we are still working on this project. Okay, because it is difficult to control such device. So we are working on the mathematical model of this, and then we will design one controller for this device. Hopefully, we will be able to develop a very cheap Ornithopter. Okay. Now the another project which we have carried out in this design lab, that is using your thermal camera. We have tried to monitor the devices at the substation. The project was carried out at Asoj substation, GUJCOST, Vadodara, and which has the voltage levels like 400 kV to 220 kV, 220 to 132 kV. It is something you can see the transformers, the step down transformer system. So what we have done, infrared thermography technique were used to diagnose the electrical power substation, which allow us to know, based on its temperature level, whether the failure is there or it is prone to failure or not. That you can do it. And let me tell you, this project is further extended by learning the image processing algorithm and machine learning tool, so that immediately you can get the idea which particular device is faulty. Okay, so machine learning algorithm is also used. So here you can see this is a 220 kV pushing terminal connector. So here this is the actual picture by your ordinary camera, and this picture we have got it through thermal camera. So you can see the temperature here at the connection point. Okay, so you can use this image for identifying whether it is abnormal or normal. Then you can see this is 400 kV CT terminal. CT means it's a current transformer. Okay, so here also this is a picture actually, and this picture you can see the terminal side. At that point you have a high temperature, so you can monitor this device. So here this is 400 kV pantograph isolator. Pantograph isolator is used for isolating the two areas. So here you can see there is a heating at the connection point. This is a 400 kV. Then you can see this is a wave trap in substation, where you can see the high temperature is there at this point, junction point. And then you can see 220 kV center break isolator. So this isolator is used for isolation purpose. So here you can, it is acting like your switch at your home. You can detach these two terminal here, the red circle, and you can isolate some of the part of your substation even. So here you can see the high temperature is there. Then here you can see this is a current transformer. So here this terminal you can see is very hot over here, this part. So you can monitor the substation using our thermal cameras using this. Here you can see this is a disc insulator, and here you can see there is a breakdown in this disc. So you can identify the fault at the insulator level using this kind of thermal camera. So this is the one project which was done by our UG students, and we can carry out such projects using the thermal camera. Then the another project which is developed by our UG students, that is, you can see that there is a drone. This is completely in-house built drone is there, and we were trying to design the controller for this drone flight control. Okay, so here you can see we have used a chip, and we have some motors are there. Of course, motors are not from design lab, but we have tried to develop this thing. The another project is very important project where we have used some sensors given by the design lab, and this is robotic arm control using your nerve signal. So here you can see how one can have the motion of your robotic arm using the gears. So we have used some sensors for this controlling this robotic arm. You can see. Okay. So this is how one can use the design lab component. We have also some of the projects which are under development. We are trying to develop a grid integration system with the distributed energy sources, because if you have various sources, like you have wind mill is there, then you have solar plant, then you have fuel cell, so many sources are there, and you want to integrate that. You need to design some algorithm for that, and then you have to implement it. So we are using this three-phase AC DC AC converters for developing such this thing, not only for grid integration, we are using it for shunt reactive power compensation, and we are also working on the developing the boost converter for power factor control. Okay, so this is how we have used the design lab resources. But this is a very important application which we have done, that is for our research work in civil engineering, that is your electrokinetic stabilization of saturated soil. So what is that stabilization of soil? It is an alternation of properties to improve the characteristic and performance. Okay, so what we have done at IIT RAM by our student is that we have used our DC supply and some components that so that you can you can give a DC electric current to the soil through the electrodes, and which causes the pore water to move from positive electrode to negative electrode because of electro-osmosis. So this is a electrokinetic stabilization, which includes the processes like electro-osmosis, electrophoresis, electrolysis, and electromigration. And in this project, that we have used a combination of all these processes, and various objectives are being fulfilled using this resources of design lab. So here you can see the other various uses of design lab we have done during this pandemic period. We have written some project proposals, that is a collaborative project with IIT Indore to establish a technology innovation hub on bio-inspired system. That is one project proposal we have submitted, where we have shown that we have this design lab resources. The another project proposal is on interactive system technology innovation hub under the bio-cyber physical system theme, which is under the National Mission on Interdisciplinary Cyber Physical System, SCRB, Department of Science and Technology, Government of India. So we have used these resources for fetching the more resources from Government of India. So in a nutshell, I can tell you that these resources are really a boon to all of us. We can use to implement our own ideas into a product or into a prototype project. With this, I am stopping my presentation, and if you have any question or query, you can write to organizer. And at the same time, once again, I would like to thank the DST, Government of Gujarat, the GUJCOST, Saucer, Jatin Bhai, and all the team involved in this particular project. Thank you very much.
Thank you very much, sir, for such informative sessions. I'm not sure about student, but I really feel very excited by looking at the project that you have developed at IIT RAM. I mean, the ornithopters, the robotic arm, all I have seen previously in the movies. But now the time has come that we can convert that movie creatives into the reality. So it's really inspirational for all of the students, and definitely the student will be motivated to design something new using the design labs. I have requested the students to drop the questions in the chat box. So definitely at the end of the sessions, we will be addressing that questions and the queries from the students. So thank you very much, sir, for such informative and motivational, informative sessions. Thank you very much, sir.
Thank you all.
Now we are moving towards our second sessions, and I'm going to introduce our second speakers of the day. He is Dr. Nitin Khanna. Sir is assistant professor at IIT Gandhinagar. Sir has received his BTech degree in electrical engineering from IIT Delhi, and he has pursued his PhD in electrical and computer engineering from the Purdue University, USA. Sir was also associated with the same university for his postdoctoral research studies for the 3 years in the field of video and image processing laboratories. Sir has joined the IIT Delhi in the year of 2015, IIT Gandhinagar in the year of 2015, and he leads multimedia analysis, security labs, and so many aspirational projects. His current research interest includes broad field in the signal image, video processing, particularly multimedia security, signal processing for the healthcare. And Sir is going to deliver the topic on the brief module of CCTV surveillance and the thermal surveillance modules that has been delivered under the design labs. Sir is also a technical committee members of the design labs, and we have received so much guidance and supports from the sir to deliver these concepts to the various universities and colleges. So again, thank you very much, sir, for your kind consent and sharing your valuable time with us. I would like to request Dr. Nitin Khanna sir to deliver his lecture. Thank you, sir.
Thanks a lot for the introduction, and thanks a lot for the organizers. I think the presentation mode should be turned on. I'm not able to
Akshay, sir,
share.
you have to stop your presentation so Nitin sir can.
Yeah, I'm stopping.
Thank you, sir.
Thank you. I'll try one. So, okay. I hope my screen is visible now.
Yes, sir, it's visible.
Okay, great. So, sometimes there is some small delay, so we have to just tolerate that. Okay, good morning, everyone, and welcome to this orientation and training workshop on Design Lab, organized by GUJCOST. This has been I've been associated with from the very beginning, and it has been a very interesting and inspiring journey of the effort taken by GUJCOST to bring actual products in the hands of students, so whatever they are learning in the courses, in their theory courses, they can actually experience by building systems based on that. And that's actually very relevant, because oftentimes our students get into engineering disciplines without having much idea of what exactly it is about, and if they don't do hands-on things, it remains a theory even after completing their degree. So this is a great initiative by GUJCOST, and I've been seeing some of the projects which have been conducted under this design lab till now, and it's inspiring to see that a lot of things have been developed. Okay, I'll just turn it to tablet mode so that I can write also while speaking. I prefer drawing on things and while I'm doing this. Okay, so what I'm going to talk about is mainly this aspect of surveillance using multimedia. So I'm just leaving it to multimedia instead of a specific just videos, because images and audios are also quite often used for that, right? So let me see how to... Okay. So what are the specific equipments we have in Design Lab? So specifically relevant to this aspect of surveillance, right? So we have a wired CCTV camera system, we have wireless CCTV camera systems, and we have thermal camera systems as well. So, okay. there is some issue in my slide presentation. Let me just fix it first before I start doing this. It's good that I got few minutes head start, so I have few extra minutes to take care of. Sir, is it visible properly now?
Yes, sir. It's visible, sir.
Okay. Probably there is some delay just because of the lag, but okay, hopefully. So, yeah. So we have these components, and one thing I would like to bring to the attention of the students when they are organizing any kind of projects based on these components is to be very clear about what kind of specifications these devices have, so that you are clear that what your objective of the project is actually going to get fulfilled. For example, let's pay attention to this wired CCTV camera system, or even the wireless one. It says in the specification that the storage space for these are 1 terabyte, right? So what it is actually mean is that you can keep them on a ongoing fashion, and they'll keep on recording the incoming video feed up till the device capacity of 1 terabyte is full. And now, but that doesn't give you much information. What information you actually need as a student when you're developing a product or as an engineer is how much time duration actually it implies, right? So from this data, that your images, this says the specification of the bullet camera says 2 megapixels. So what does it imply is that each of the images coming from the camera is of 2 megapixel. This 2 megapixel is still in terms of pixels, so you only get that, okay, out of this image size, what's the number of columns or the number of rows. But from here, what we need to know is how many megabytes of storage or kilobytes of storage it is going to take, right? That, and then with the help of that, you can calculate, okay, how many total images this thing is going to store, because that's what the relevant number from your design perspective is, and not actually images. We actually need to know what is the video duration it's capable of storing, right? So that way, you know that, okay, if I am designing a system, my system will be able to store continuous videos for n number of days or x number of hours, and then after that I have to program it so that it keeps on overwriting on the same storage space, so previous ones are deleted. And that's typically most of the these video surveillance systems are designed in a default way, in that fashion, that so they talk in terms of, okay, 10-day limit, 30-day limit, that previous 30-day data is kept, and after that it keeps on overwriting on the same thing. Okay, so that's important to notice, and this video duration will depend on this. In turn, is going to depend on a number of other factors. That, okay, how many frames per second you are going to store, right? So these, say, typical what you store is 30 frames per second, 30 FPS. That means basically every second you are getting 30 frames, or you can think of 30 images of the size 2 megapixel each. If the frame size for each of the videos are 2 megapixel. So these parameters you have to take into account. And then when you are configuring, since you are going to configure this system, so you will also have option of, okay, what is the storage format we are going to use into it, right? So you might be storing this in the videos in .mp4 format or .avi. So there are trade-offs involved in that. So basically these video formats, what they do is they are going to reduce the size of the video tremendously instead of just storing the raw video. But what's the cost? The cost is that the trade-off is going to, on the other hand, that we'll need extra resources to compress the video. And remember, we want to do all this in real time because the video frames keep on coming. So how much compression you can perform depends on how much computation power your video surveillance system has and how quickly you are feeding the video. Right? So 30 frames per second, 10 frames per second, or 100 frames per second, what exactly you want to store. So depending on that, to make sure that as soon as these raw data is coming, you keep on compressing and saving them in a proper format. So those kind of finer details of the system are very important to be kept in mind when you are designing a system as an engineer. And that's important for us to take in all of these applications. Okay. So then the wireless one has similar specification. The benefit is that you don't need to connect all those wires. But my main focus on this discussion today is going to be more on the processing side, or how we are going to design products based on that. So we'll not differentiate those too much. But in the wireless one, you will also need to take into account if the system is going to be battery operated, then how long the battery is going to last, and how long you can monitor this thing. So there are lots and lots of projects which can be done based on these components, and and combining these with number of other components which have been provided under Design Lab. And some of the other things which will be required might be already available in your institute's lab. So given the constraints of time, we'll focus on few of the applications just to give a taste of what kind of things can be done. And then sky is the limit. As the student's mind, that's the whole idea was of the design lab, to let the student think and come up with new ideas. So for new ideas, there is no limitation. You can come up with so many things. Okay, so let's go to the next component. So next component is, so idea is I'll first tell about the components and then some sample projects which can be done based on that. So compact thermal imaging system. This is compact in the sense this is a handheld pocket-sized camera which will give you thermal images. So this is really nice, and even nowadays some of the cell phones are also coming with thermal imaging. So that doesn't seem so exciting nowadays, but think about a decade or so ago when none of the thermal cameras were pocket size. You had to have a bulky thermal camera, and even if we go back in past some more time, we'll find the thermal cameras needed a sophisticated cooling system, because what essentially the thermal camera is doing is measuring temperature, and if you want to be very sensitive about measurements, that you don't want to make too much error, you are going to deploy a very high-end sensors for each of the temperature measurement, and then a sophisticated cooling system might also be needed if this temperature measurement itself has to be done for a wide range. For example, let's think this specification. So this camera, it says that it's going to measure temperature in the range of -10 degrees to 150 degrees. So ice to boiling water, and beyond that, extending beyond that slightly also. So this kind of sensors were very hard to build in a compact size, but thanks to the advancement technology, now we have in the handheld. So a lot of applications which are not feasible because of restrictions of hardware now have become very easy to do and conceptualize and build. Right? So another thing, as I was mentioning, that you take into account specification related to accuracy. So this thing basically says that it's accurate up to ±2 degrees, right? So let's think about application. Can we use this FLIC2, this particular camera, for measuring human body temperature and solving our problem of like temperature detection in COVID scenario, where you at every entrance point you need to know the temperature of the person, and if it's beyond a certain range, you need to alert. So in that, if you are thinking that kind of application and we want to try to use this camera, we have to take into account that accuracy is only ±2 degrees, and that might not be enough for a specific application, because the human body temperature, so what it says ±2 degree basically is if it is 30 degrees, you may be saying 32 or 28. Or if it is 98 degree Fahrenheit, your camera may be giving you 102, 102 degree Fahrenheit, right? But that 3.6 degree Fahrenheit change in body temperature is a great amount of change for detection of COVID to non-COVID, or high elevated temperature, elevated body temperature to non-elevated body temperature. So basically this application which I was talking in terms of COVID scenario is the detection of elevated body temperature, that's referred as SHORT. So this body temperature, if you want to measure, so you have to make sure that your camera is much more sensitive, which will give you accurate answers, and you don't misclassify persons so often. So that's one example as me. But this camera with plus minus 2 degrees centigrade accuracy is very well useful, as Professor Akshay was demonstrating you, for say measuring faults in transformers or in many other electrical appliances, or measuring energy dissipation happening in buildings, or leakage point detection in buildings, where the temperature range is going to vary drastically. 2 degree change in temperature in a transformer is not a critical thing. So even if your device makes 2 degrees centigrade error, that's not a big thing. But what you're going to detect is much larger temperature difference, 10 degree, 20 degrees. So that kind of differences, this camera will easily detect. So for designing applications, again, bringing home the point that we're very critical about the specification of the device you are using and what kind of requirement your particular application has. And another point, let's pay attention to that the sensor size for this camera is 80 into 60 pixels. That means this is going to just give us a small image, 80 by 60, these kind of images. So it is going to measure 4800 sensor points are there for the IR camera. While you see in the same camera, the digital camera is of much higher resolution. That also indicates that how there is a huge price difference and trade-off in designing compact thermal imaging cameras. So that's one device in the list of design lab. Next component let's talk about is this thermal camera for product inspection. So this camera has a much wider range. If we compare with this was minus 10 to 150 degrees, and this one has minus 25 to 380 degrees centigrade. So this is for specific product inspections of say chemical plants where boilers are there. You want to detect if some specific points are getting too much heated. So that kind of detection can be done. This like kind of point and shoot thing where you point it to a specific portion and it tells you the temperature of that. And accuracy of this, if you will see, this is slightly better, 1.5 degrees centigrade. That's again a great amount of accuracy for industrial inspection point of view. So a lot of applications can be designed based on that. You're designing a electronic system. You want to detect which part of your system is getting heated most, where the cooling is necessary, or whether that heating is within tolerance limits of the system or not. So this will come a lot handy. Okay. Next, okay, so now before I go into sample projects, I'll just say that these are collected from various sources on internet, and latter part of the thing I'll also discuss some of the projects which are going in my lab, particularly related to security of the multimedia, which are not based on these equipments, but some of these equipments can surely be led into that direction. So this the idea is for me to give an indication of some other applications which can be built on top of these things. Okay, so for example, let's look at the typical video surveillance scenario. The most one of the most basic, I will say, is number plate detection. Okay, so we want to detect the number plate on moving vehicles, right? So so now you have these camera system which you can mount. So as an experiment, you can mount at the entry point of your college gate or some other location, and then see if you can monitor traffic coming to the college, right? So first step is going to be deploying in a proper position so that you capture the whole field of view properly, and then after that, within that field of view, you don't want too large a field of view, that so to say, you don't want to capture twice this amount of road, right? You just want to, if you're monitoring one lane of traffic, you only want to capture that much, because if your field of view is smaller, each of these characters which you're going to see at the end, and which we need to detect what exact number it is, we will be able to see in a bigger size. And then when you see the bigger size, next step I'm going to talk about is how to automate that. So that step is going to be much easier, the automation using computer vision algorithms, right? So that's one aspect of deployment you have to think of. And so that's one application, detect the cars, then within the car detect the number plate, then after number plate detection, we deploy some kind of OCR algorithms, optical character recognition. And now when you're building systems, a lot of components of these systems are going to be already available in a at least in a most basic form. If you go to some of the libraries like Python, or even a lot of C libraries, C and C++ libraries are there, where number of components are available. So you don't have to build every component from scratch. For example, this OCR, optical character recognition, need not be built from scratch, because the OCR is a long-term, very long-term technology. A lot of open source development has already happened. So what we need to do as a student is we need to see which particular library is suitable for deployment in my application. So there is a open source OCR by Google, TestRack. There is, I think Adobe also released its own older version of open OCR as a free product, open source. So a lot of things can be done. So, and basic Python and C and C++ programming will be needed to utilize them for particular automation. What I'm going in this direction is, so computer vision based automation. That's what we want to do. So one aspect is the deployment. So nowadays, if you see, most of the these video surveillance kind of systems are deployed for capturing the data. So a lot of data capturing is happening. CCTV cameras are there at a lot of places, but the real-time processing or information extraction from those video feeds are not happening. It's mostly after the effect or after the event analysis. So say in an ATM, some robbery has happened. After that, we go back and analyze the CCTV footage of the ATM to find out, okay, who was the person who was responsible. But what it will be great, the next great step, which a number of researchers all over the world are looking for, is to build real-time monitoring systems without the human involvement, or with minimum human involvement. Okay, because you don't want a human observer sitting, but that's what is happening in malls and other places also. We'll see human observers sitting and monitoring the feeds from 10 different cameras. Now that's human intensive, but another bigger problem is that if human mind is not so trained for observing 10 video feeds on a small screen camera or even 2 or 3 cameras, so there are large chances of making mistakes because of the tiredness issue, and there's your brain gets saturated with the amount of information coming. So this automation is going to be the next big thing. A lot of places it is coming up, and a lot more opportunities are there. So that was license plate detection example. Then after that, this is showing another example where on a railway track, you want to see, okay, some portions of the track should not be populated by human population. So basically it is about generic problem, if you think of, is a scenario where you want to locate some object which is in an environment which is prohibited for that object. So a interesting benefit which we get in these kind of CCTV camera applications is that most of them are actually fixed mounted. So you mount them on a fixed place, and then they are recording, right? Like you have seen at many entrance gates and things like that. So what's the advantage we get in processing is that now the background is more or less fixed. So these tracks are always going to be there like that. So now you have the history of the scene, that okay, the scene usually looks like that. We are going to see the tracks. And if we just compare the as we mentioned earlier, we are capturing 30 frames per second or 10 frames per second. So if we keep on comparing the previous frames to the present frame, we can see, okay, that here actually it is supposed to be constant white light which is illuminating the track. So if this is covered, that means some object has come over there which should not be there. So things like that. So those kind of intelligence building into the system is essential, and if the train is there in that location, then it will be full much larger coverage than this small human being covering that. So that's one. This similar kind of application you can also think about, a number of people are developed and shown also, is in COVID scenarios, a mask detection in public places, right? So to enforce that people are wearing masks, so you have to design your algorithm that it's capturing the video feed and it is real time detecting the faces, and if the faces are covered, if the nose and mouth are covered or not. So that's one. Then in this COVID scenario, while we are there, one more application you can think of is crowd detection is also very useful. So crowd detection is not a new thing. It has been useful for a long time, because we have seen or heard news about a number of accidents happening because of some kind of stampede happening, a lot of people gathering in a small place, and if the place is beyond capacity, there is no proper escape route. So if the fire happens, that's a problem. So crowd detection or density of the crowd, detecting density of the crowd is a very important problem. But now in present scenario, it becomes even more imperative to find out the crowd density in a given area, because there are a number of government guidelines about 50% capacity utilization in any given area, separation of certain amount. So those kind of things can also be built based on these video surveillance applications. And then this third example is showing traffic monitoring, where you want to monitor which vehicles are allowed in certain area and which vehicles are not allowed. So that based on the size of the vehicles, you can detect, okay, heavy vehicles are not allowed in this area. Then there is another example of parking systems, where you want to see if the parking is done properly or there is violation, and how to take care of that, or alert appropriate authorities for doing that. So these are some of the applications related to traffic mainly. Let's look at one more. So this shows another scenario where some system is deployed for highway monitoring. So the highway monitoring is slightly more different bag of problem than normal city roads, because by design city roads are much more crowded than the highways. And but the other trade-off is that highways are much more in length and across the whole India, length and breadth. So monitoring the so large network of highways using human observers is going to be much more difficult. So this automated surveillance for highway monitoring, which will come much more handy, alerting the appropriate authority if there are certain accidents have happened, or if some congestion is happening, or road conditions of the highway is getting very much deteriorated. So if the camera is very high resolution or appropriate resolution, we can use these cameras also to monitor road conditions, because as I was saying, that these are fixed cameras, so you know what a normal road condition looks like, what an empty road looks like, right? So over the period of these recordings, we have got a normal roads picture, and if there are a lot of dents happening in the road because of wear and tear, then that can be detected based on these automated processing. So that's one. Okay. Now one more point I would like to. I'll come to that in after this infrared. Yeah. So now a lot of these video surveillance applications, what images we are seeing till now, were all normal camera images, what we technically refer as visible spectrum images. But visible spectrum images are not always going to be helpful, particularly in cases of night. So nighttime video surveillance, we will need IR images or infrared images, right? So infrared images basically work on, as we saw in the specifications of the device, based on the temperature measurement. So a car which is moving on the road is going to generate heat. So that heat generated by the engine of the car is going to be detected as a bright spot in a IR image, and that can be utilized. So that is the sensor part. What kind of sensor we need to detect that information which is needed. Then after the detection, some of the applications saw, then this is some of the applications saw was in a static scenario, like in a single frame you're detecting license plate, or single frame you're detecting how much crowd is present, or mask or unmask kind of thing. Then other big set of application is when we come to what we call behavior analysis based on these systems. So behavior analysis in the sense that not only I want to detect that there is a car over here and there is another car over here, but what kind of pattern these cars are following. So over the period of next 10 second or 1 second, these cars are moving in a straight line. Okay, so this car has moved from here to here in a straight line, something like that, or they are not moving properly. So that is referred as behavior analysis, or or temporal analysis over a period of time. Right. So this specific is specific with the traffic scenario. Similar things are applicable for other scenarios as well. For example, in an ATM, you want to measure the dynamic behavior of a person who comes in the ATM. So how this kind of problem we can typically solve is think about what the typical behavior of a person entering the ATM is going to be. Okay, he's going to put his card and he's going to punch the numbers and then withdraw the cash and go. But so this now what you have to do in a we need to model the hands locations primarily, and then see in what fashion the hands are moving, and a number of different training videos can be there which will tell what is typical behavior of hands in ATM is. And if your system detects any other behavior other than that typical behavior, that possibly is a situation where some authority need to be alerted, where they can check, okay, what's happening actually in the thing which is legal or not. So things like that. So a lot of different applications will come. So for example, this shows a person running. Okay, he is running on the sideways or he is running on the road, in which order this specific person is moving. So these kind of things are useful. Say in airport surveillance, you want to make sure that people are moving in a well defined pattern for a specific purpose. You want to detect where a person has his baggage and then the person is standing over here, and then once the baggage and the person should be going together, right? So if those two objects are separated in different frames, you can think of, okay, this person is leaving the baggage some other place. So we all hear the warning, don't leave your baggage unattended. But if someone is doing that intentionally on an airport, that needs to be checked, right? And then authorities need to be alerted. So a lot of these systems can be built based on the devices which you already have. The design lab has already provided the cameras which can be mounted for the CCTV, and you already have a laptop or mini computer which comes with the design lab, and the students are learning Python coding or C or MATLAB in their regular curriculum, and now it's time to put all of them together to design a prototype system which you can train to detect a specific pattern or absence of a specific pattern, and that can very well be done within your regular lab setup as well, right? So let's say some examples. Okay, let's move on. So now some specific example of night vision. So where the IR cameras are going to be specifically helpful. So human eyes are only sensitive to a specific range of frequency, what we referred as visual spectrum, right? And we only see objects if they are reflecting light in that range, or they're emitting light in that range, right? But there are other frequencies of light which are not which human eyes are not capable of observing, but which are very helpful for a number of applications. So there are X-rays and other things, but specific to design lab, what we have is thermal cameras which work in this frequency range. So other than that, the hardware which changes, rest of the designing of the product is very similar, because once you get the images, like we were saying, traffic monitoring or behavior analysis or movement monitoring or object detection, those kind of algorithms or systems which will develop, which will remain same. What changes is the hardware. Instead of normal camera, we have the thermal camera, so that we can acquire thermal images. Now in thermal images, actually, oftentimes thermal images are presented in a like colored fashion, but those colors are actually depicting temperature values. So we cannot directly see the reading the temperature values in numbers is not going to make much sense to us. So this is the images which you generate. These are referred as pseudo color images, because those colors are not actually the red color. The object is of red color necessarily, but red color is indicating high temperature object, things like that. Okay, the object color might also be red in some case if it is high temperature, but not necessarily, right? So that has to be kept into mind. So this gives a few example images of a person. Here a person is in completely dark, so a visual camera will not be able to capture, but what we are getting is heat signature of the person, because human body has a certain temperature range which it maintains. So even in a dark you can detect that. So very helpful device, and a lot of applications can be thought based on that. This is the image of a building where it's showing different heat locations. So what I was telling you earlier, okay, that red color indicating a high temperature, blue color indicating a low temperature, things like that. So that's just a pseudo coloring to differentiate that. So you can see which locations in this building is most liable to a drop in temperature with the weather, and that place might need further insulation or things like that. Here's another example of thermal images, and using those thermal images to create some models. Okay, so at this point, one more thing I would like to bring to attention is in video surveillance. That's why I named this thing as multimedia surveillance, not just video surveillance. Any of these applications which we saw, what the by default thing can be simplest, that we just let the video feed keep on coming and we keep on recording it and then process it, either process in real time or processes later on. But as we saw that in the specifications, the camera comes with 1 terabyte of storage. So that will limit how much video, how many days of videos you can record. So an interesting design can be on top of this, the project which you can design is trigger the camera to record only if certain events are happening. Think about if you design a sample project of monitoring the front gate of your university. It's not the traffic is always coming and going. In a normal day, there will be number of periods across the day where there will be very less traffic. So you don't need to keep on recording 24/7. So what kind of project can be designed is to trigger the recording mechanism only when certain events are happening. And it depends on the particular application or scenario, or what is the critical observation we want to make that the recording is turned on. So for example, in certain scenario, if we may want to trigger the recording only when some audio, some noise happens, right? So what you can do is design a product which takes input from a mic and then detect the sound. So again, you have to utilize the fact that this sound and mic system, you have placed the mic system in a particular location. So what's the normal ambient noise level of that system? You measure it for a certain time, that becomes the threshold. And if the noise level goes beyond that threshold, then we want to trigger on our camera system to start capturing the video feed. So that way your 1 terabyte of storage, which is limited to say n number of hours, that can store much larger than n number of hours. And particularly for wireless deployment and other things, if they are battery operated device, we will be able to save a lot on energy as well. So a single battery charging will last much longer duration. So these things become very critical in applications, particularly when we want to deploy these systems on some remote locations where power is an issue, 24/7 power supply might not be available, and cost is also an issue, and battery life is an issue. So these different sensors, or you can have a IR triggered mechanism to record, right? That in the night vision system, you don't want to keep all the lights on all the time on the roads, right? On say from the front, whatever observation place you have. So instead of keeping that on, if there is activity detected by the IR system, then the light can be turned on, connecting with that. So this is where other parts of the whole design lab kit will come into play. A Arduino crate, a USB, other smaller components, a microprocessor, which can help you trigger these things and then give a signal to the next system, which turns on the lights, and then you turn on, after turning on the light, you turn on your visible spectrum camera and start capturing the video or doing some other kind of analysis. So combining them is going to give us a lot more interesting products. Okay. So next around 5-10 minutes I like to spend a slightly new aspect of multimedia surveillance or video surveillance, which up till now was not so much explored, because the deployment of video surveillance system was itself in progress. So we are not so much worried about how to secure them itself. So now we saw that a lot of applications where we can utilize these inputs coming from these cameras to detect a number of events: public safety, crime detection, fraud detection. We can as well use them for healthcare applications. That's another thing which is nowadays very important in this COVID scenario. Is if the hospitals are running overloaded with patients and we have limited number of nursing staff, we cannot deploy nursing staff in each and every room, right? So we may want to remotely monitor the patient's well-being in the room, that they're able to lie down on the bed properly and they're moving, or they need any help or not. So these kind of video surveillance have lots and lots of applications. And when we combine them with automation of object tracking and other things, that becomes even more interesting. So now, going forward in future, we are going to become more and more reliant on these automated surveillance systems, right? But the question will come: how do we make sure that the media itself, or the images or videos which we are receiving from the sensor, that itself is authentic? And if that authenticity of that is itself is in question, then whatever decisions we are going to make based on that is going to be problematic. For example, what I'm coming to is, we are recording ATM videos and then afterwards analyzing whether some bad incident has happened or not, right? But what if the ATM video itself is tampered, right? Someone has changed a few things, or someone has deleted something in between or inserted something. So those kind of questions can only be answered if we are very sure that what video or what images we have received and we are using for surveillance are themselves correct, right? So that brings to, so there was one aspect we discussed till now, was security using the multimedia, using videos. Now we can think about security of the video itself, of the images themselves. For example, let's look at this image. So this image appeared in New York Times and other websites that are supposed to be trusted some time back, and it was showing, say, testing of some missiles. But later on, it was, so looking at just this image, it seems normal. We cannot by looking by human visual perception, we cannot figure out, okay, this image has something wrong. It just seems it's okay. There are 4 missiles being tested and stuff. But if we compare, later on it was found out that actually the original image contained only 3 number of missiles, and by manipulation extra missile was added there. So if you compare these two face to face, that's easy to grasp, but just by looking at this false image, it's very hard to see for a human being that, okay, this is a false image. So this kind of questions about trustworthiness of the video and images themselves come into picture as we go into future building systems based on utilization of these video and images feed. So I have given some references. Interested students can go and look into more details of it. So this becomes, and there are other challenges more and more happening, because the amount of content generated day by common person is increasing. That's one challenge, is the content. Huge amount of content is one challenge. The other, side by side, what is happening is editing softwares are becoming very easy. So nowadays actually you have come to the lot of applications come in these mobiles itself, which will allow any normal user to edit the images, delete some faces from it, or add something to it, or change the background. Sometimes, or actually most of the time, might be for a normal user it's just fun and there is no critical implication of that. But we cannot deny the possibility of misuses of these things for when these images or videos are used in some critical application. So as we move on, we have to also think about security of these contents themselves. So that's I wanted to point out too. And then there are other news also items. You will see what kind of forgeries are happening with the printed documents or hardware, because nowadays, especially since think about this COVID scenario where these universities are closed and a lot of paperwork is just happening by sending a scanned version over the email and accepting that as reality, and then moving based on that instead of hard copy printed documents. Now, once the document comes into the scanned format, it's quite easy to manipulate or change it, because as we say, editing of digital images is much more easy as compared to editing of your hard copy documents, right? So a lot of questions will come into about security of these things, and that need to be answered by developing systems. I'll not go into detail in interest of time, but in our lab, we at IIT Gandhinagar in Multimedia Analysis and Security Lab, we have been working on developing a number of systems for detection of these kind of tampering or changes which have been done in images or videos or printed documents. So this is an overview of a system which works for images. Now, this shows some of the results of work done in our lab. Okay, this portion of the image was this is the original one, was changed. So our algorithm was able to detect, okay, this is the false location, and the number of other examples and comparison with some of the other things. This GT refers to the ground truth, where actually the forgery is happening, and then there are three systems which are detecting what kind of forgery has happened. So now to secure this kind of thing, this is, I think I will close on this slide. There are two main ways to do it. One is called watermarking. A lot of us are familiar with this term watermarking. You have seen in currencies, a specific kind of watermark is there, either a silver lining is there, or you view the currency note at a particular angle, it will show you different things. Similar kind of experience, but with digital images or videos. So in the watermarking, we will have visible watermarking and invisible watermarking, some broad category. There are a lot of details. We don't have time to go into that, but we can think of developing applications based on that. So your particular camera, which is by default coming in the design lab kit, gives you a stream of video coming in, but that doesn't secure the stream anyway. You design a software or a system on top of that, which will get this raw data and embed a watermark. In the watermark, in the sense that, suppose a very basic one can be at the corner, you embed that, okay, this timestamp you can just add to it. Some of the mobile phone apps come with that functionality, embedding the timestamp. So this image was actually captured at this time instant. So you cannot do the frame repeat attack or that kind of thing, where in a video surveillance system a single frame is looped multiple times, and then it seems that there's no motion happening in the scene while a lot of things are happening. So that's a simplistic example of visible thing. Then more sophisticated things can be invisible watermarking, so that it's because if you do visible watermarking, then the attacker also knows, okay, which portion of the scene need to be changed. Okay, this timestamp you're inserting, okay, I'll remove this timestamp by doing some other sophisticated image processing technique. Invisible watermarking, attacker does not know where you have inserted the time stream. So there are a lot of algorithms which can be based built on that. I see I have only 1 minute left. So last minute, I'll just point. The other thing is sensor forensic, where we don't embed a watermark because of many reasons. Might be the camera itself originally was not equipped, but what happens, we use the device signature itself. So we extract some features which represent that device. So there is a huge deal of science behind it, the way the images are captured. So that basically comes from how these images are captured. So you need to utilize your understanding of how actually digital cameras work, and based on that, then you build your projects. So couple these hardwares which you have got with your understanding of the working of this camera which you learn in your theory courses, and then build some system which will not only utilize these images and videos for security, but also secure them, the images and videos themselves. So with this, I think I'll stop here because the time is over. Let's please go ahead. Let's see if we can address some questions.
Thank you very much, Nitin sir, for such idea-provoking sessions. I think this will definitely inspire the students to think something out of box. We have received a few questions, and I wanted to address that questions right now. The first question is, I think, to the Akshay sir. The student is asking, is it feasible to use Arduino kit and Bluetooth together to develop a power system projects like harmonic reductions and fault detections?
Yes, why not? It is possible.
Okay, can you give some insights how they can do it?
Actually, Arduino is one kind of Arduino Uno kit is a one kind of processor, So whatever the signal you are getting through your Bluetooth, that you can use it for programming certain things, and then you can put it in a closed loop, So some power system related application is there, and you want to switch on or off, and you want to get the data through Bluetooth, wireless, through your Arduino Uno board, then it is possible. Only you need to refer the compatibility.
Okay, sir. The second question is from the students. He's saying that there is one toolkit that is a smart home network kit being provided under the design lab. So, what is the range to operate that kit? And if someone want to build up some system where the motor or water pump at the farm can be turn on and turn off, then how they can put up this smart home kit in such project?
Yeah, in a smart home kit, it is actually using the Wi-Fi network. So if Wi-Fi network is available wherever, your own Wi-Fi network, maybe at a pump house or maybe at some other distance, but if your Wi-Fi is available in a range, then the smart home kit can be used.
Okay, so it's not a problem of distance.
No, not at all. It should be in a Wi-Fi range. That is the only requirement.
Yes. Agree with you, sir. One more question is for Nitin sir. The student is asking what are the upgraded version of FLRI C2 or TG165 camera available in the market? Because the highest range is 350 degrees Celsius. So if they want to measure beyond that, what could be the possibilities?
Yeah, good question. So actually, I think around 3 years back or something, we finalized this model. So now even FLIR C5 is also there, but anyway, so for the other inspection product also there are other higher end and newer FLIR systems are there. But the other challenge may come if we want to go for very wide range is cooling requirement. So these the bigger thermal cameras which will support much wider range and higher temperature values or very low temperature values will typically require their own sensor cooling. So that might not be feasible for a handheld device. but other devices do come with support. And FLIR is just one of those companies which are making such. There are other companies which are also providing these devices.
Okay, so the latest version is available in market that can be used for the long range of thermal detections.
Yes.
One more question is, sir, if a student want to build some of the system using this camera, then how they can interconnect or do coordinations between automations and this camera? Is there any other tools in the design lab which can be useful for making some autonomous systems using this camera?
Surely, it will be a good idea to do that. These cameras support recording. I don't have actually these cameras actually in hand, so Professor Akshay may comment more on that. But I believe they support not only just recording on board in the 1 terabyte storage space they have, but they also live stream that to a desktop or a mini PC or something via a HDMI cable or Fireport cable or some other kind of cable. So once this we connect it with live streaming to one of the PCs or similar devices, then there are libraries or SDKs, development kits come which will allow you to capture these frames in real time. And on top of that, these SDK will also come with some of their built-in functions and also allow one to write scripts in Python. And even MATLAB has an interface which allows you to connect to some different camera models and then do the analysis in real time. So basically the SDK provided by the supplier, then Python and MATLAB libraries, those can be helpful to connect. And then the connectors are of course there. Professor Akshay, please go ahead.
Yeah, adding to your point, it is possible to devise some robot or some cubot kind of application where you are capturing the image in real time and you are processing it and you are developing some controller algorithms. We have one such robot in our laboratory that is called cubot. So where we capture the image and based on that it has to follow certain path or follow certain signal. We are giving some signal like red, green, and yellow. So your robot will actually follow that signal. Then we are also giving the path planning trajectory, or you can say the trajectory on which your robot can move. So all these applications are based on this image processing. But one thing is required in all this application. You need a real-time interfacing software.
Yes, sir, agree.
Perhaps we don't have in our design lab. So you may use some third-party software to interface the image captured and your device. Because in device you have robotic motor, as an actuator, you have motor, servo motor kind of thing. So you need some interfacing software. So that is the only requirement.
Okay, sir. I hope student get their answers. One last question is, I think for Nitin sir. Student is asking, is there any applications of cameras, thermal cameras in building an autonomous driving system?
Yes, definitely that will be important because these autonomous driving systems, we want to work them at the night time as well, right? So for the night vision applications, we will definitely need these kind of thermal cameras for detection of pedestrian, detection of traffic or cars ahead. Although you have the headlight of the car itself that gives, but in the night time that visibility of other objects is not enough from the normal cameras only, so we'll need thermal camera images as well.
I think we have covered almost all the questions that has been raised by the students. So again, thank you very much to both of the research person of today's session, Akshay sir and Nitin sir, for delivering such insightful talks. And we also are thankful to the students who joined with us today for today's sessions. We have another sessions tomorrow on the same times where Dr. Vishwajit Sharma and Professor Raj Haqqani will be joining and delivering sessions on another modules that are available in design labs. So thank you very much. I think we are done for today. Akshay, want to say something?
No. Thank you very much.
Yeah. Thank you, sir. Thank you very much.